Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the stationary random process. This is the previous examination question. The example is, consider a random process x of t is cos of omega t plus theta, where omega is a real constant and theta is a uniform random variable in 0, pi by 2. Show that x of t is not a WSS process. Also find the average power in the process. Coming to the solution, given that the random process x of t is equal cos of omega t plus theta. So now here omega is the constant and theta is the uniform random variable. Theta is the uniform random variable over the interval 0 to pi by 2. So we know that the basic expression of the probability density function of the random variable x is 1 by b minus a over the interval a to b. So now here theta is a uniform random variable, the interval is 0 to pi by 2. So in this interval, the uniform probability density function of the random variable theta is f of theta is equal to 1 by pi by 2 minus 0. So 1 by pi by 2 minus 0 is pi by 2. 1 by pi by 2 is 2 by pi over 0 to pi by 2. So this is the probability density function of the uniform random variable theta. So the condition for Whiteson stationary random process, the mean value and correlation function of the random process is a function of time, then the random process is not a stationary. The mean of the random process is a function of time t, then it is known as non-stationary process, and autocorrelation function of the random process is also a function of time, then the random process is said to be a non-stationary random process. That is the condition for non-stationary random process. And stationary random process means if the mean of the random process must be a constant and autocorrelation function is depends upon only function of tau. So that is the condition for stationary random process. And this is the condition for non-stationary random process. First, calculate the mean value of the random process x of t. We know that expectation of x of t is equal integral minus infinity to infinity x of t into fx of x dx. This is the basic expression. So now here expectation of x of t is equal integral minus infinity to infinity x of t into f of theta d theta. So now your f of theta value is 2 by pi over 0 to pi by 2. Applying the given data in this equation. So expectation of x of t is equal integral 0 to pi by 2. So given that x of t is cos of omega t plus theta and f of theta is 2 by pi into d theta. So now we are integrating with respect to theta. 2 by pi is the constant that is written before integration, that is equal 2 by pi integral 0 to pi by 2 cos of omega t plus theta d theta. Integral cos of omega t plus theta is sin of omega t plus theta over 0 to pi by 2. Now substitute upper value of theta and lower value of theta. We get 2 by pi into sin of omega t plus pi by 2 minus sin of omega t plus 0. Sin of pi by 2 plus omega t is minus cos omega t minus sin omega t. Okay, cos of pi by 2 plus omega t is sin of pi by 2 plus omega t is cos omega t. So that is equal expectation of x of t is equal 2 by pi into cos of omega t minus sin omega t. So now here the mean of the random process is a function of time t, depends on the function of time t. Therefore the random process x of t is not a stationary random process. Next, find out the autocorrelation function of the random process x of t. So the autocorrelation function of the random process x of t is Rxx of tau is equal expectation of x of t into x of t plus tau. So now substitute given random process x of t here. X of t is cos of omega t plus theta and x of t plus tau is cos of omega t plus omega tau plus theta. So now here the within the bracket term is 2 cos A cos B. So now where the 2 is missing, multiplying numerator and denominator by 2, our xx of tau is equal to 1 by 2 into expectation of 2 cos A cos B. So 2 cos A cos B is cos of A plus B. So expectation of cos of omega t plus theta plus omega t plus omega tau plus theta, that is cos of A plus B, plus cos of A minus B, cos of omega t plus theta minus multiplying minus in the bracket term minus omega t minus omega tau minus theta. So now the second term plus omega t minus theta plus theta is the cancel, and the second term is cos of minus omega tau. Cos of minus omega tau is cos omega tau, and applying the expectation into each term, r xx of tau is equal 1 by 2 into expectation of cos of 2 omega t plus omega tau plus 2 theta plus 1 by 2 into expectation of cos of omega tau. So using expectation of x of t expression, expectation of this term is integral 0 to pi by 2 cos of 2 omega t plus omega tau plus 2 theta into density function of the random variable theta, that is 2 by pi into d theta plus 1 by 2. Expectation of this function is using expectation of x of t expression integral 0 to pi by 2. Now the function is cos of omega tau into probability density function of the random variable theta is 2 by pi into d theta. So 2 by pi is constant, that is written before integration here and here. Here also cos omega tau is constant. Now here integration with respect to theta. Cos omega tau is constant, that is written before integration. So integral cos of 2 omega t omega tau plus 2 theta integration is sin of 2 omega t plus omega tau plus 2 theta by 2 over 0 to pi by 2 plus integral 1 d theta is theta over 0 to pi by 2. So now here the substitute upper value of theta and lower value of theta. Here also substitute upper value of theta and lower value of theta. We get 1 by 2 pi sin of 2 omega t plus omega tau plus pi minus sin of 2 omega t plus omega tau 0 plus 1 by 2 cos of omega tau 2 by pi into substitute upper value of theta and lower value of the theta in the second term pi by 2. So now here 2 by pi into pi by 2 is the cancel. Now here sin of pi plus 2 omega t plus omega tau is minus sin of 2 omega t plus omega tau minus sin of 2 omega t plus omega tau plus 1 by 2 cos of omega tau. So now here minus sin of 2 omega t plus omega tau minus sin of 2 omega t plus omega tau is minus 2 sin of 2 omega t plus omega tau. So that is equal Rx of tau is equal minus 1. Now here the 2 is the cancel numerator and denominator minus 1 by pi into sin of 2 omega t plus omega tau plus 1 by 2 cos of omega tau. So now here the autocorrelation function of the random process x of t is depends on function time t. Depends on function time t. Hence the given random process x of t is not a wide sense stationary random process. So next find out the average power of x of t. So we know that the average power of the random process is expectation of x square is expectation of x square of t is equal rxx of 0. So now here rxx of tau is already calculated. In that equation tau is substituted by 0. We get expectation of x square of t is equal minus 1 by pi into sin of 2 omega t plus omega into 0. Tau is equal to 0 plus 1 by 2 into cos of omega into 0. So cos 0 value is 1. Now here therefore expectation of x square of t is equal minus 1 by pi sin of 2 omega t plus 1 by 2. So this is the value of average power of the random process.